Hello, Course 3 students, and welcome to our lesson 3.3 in our chapter 3 unit, which is about interpreting graphs. So now that we know how to plot things on a coordinate point or coordinate grid, we are going to talk about graphing more so, and we want to be able to understand and interpret what these graphs really mean. So we're going to see kind of graphs like this pictured here. We might see other types of graphs, and we want to explain what do those lines within the graph or the dots on the graph, what do those really mean compared to what kind of problem it is. So our lesson objective is I can interpret information given in a graph and make a graph to model a situation. So interpreting if you're given a graph and interpreting what it means, as well as giving information and then creating that graph. All right, so a couple different key ideas here. I took these straight from the book, so if you do have a copy of the book, you can look in there as well. But the first one over here, it says that graphs can be used to model a variety of situations. For example, a graph can show the relationship between a snowboarder's speed during a race and the time since the race began. Trends in the graph indicate whether the snowboarder's speed is increasing or decreasing. To relate a graph to a given situation, use keywords in the description. So we could even go back and look at the one I put up here because this talks about time and position, and think about that snowboarder situation and figure out, kind of looking at this part, you kind of want to separate it based on how the lines are going. So there's kind of like 4 parts to this type of a graph. So first off, maybe, he was at position 20, didn't move anywhere. He's not going up, he's not going down, he's just staying there. Then at 1 second starts moving, increasing, gets to distance 60, then stays there for a while. And then their speed starts decreasing as they move back down to 20, or their position as they go back. So that's kind of one way to put it as that. So that's what we're going to take a look at here first. The second part is talking about what kind of graphs they are. So there's 2 main graphs. This would be really important to write down, I believe. I think it'll help to remember what type of graphs these are. So it says a continuous graph is a graph made up of connecting dots or curves. The graph in example 1 are continuous graphs. So this is a continuous graph. It continues on with lines, it's going up, going down, they're connected. A discrete graph, though, is a graph made up of distinct or unconnected points, which actually you see right over here. The graph on photo printing costs is an example of a discrete graph. So basically, continuous graphs are going to have lines connecting things. Discrete graphs are going to have dots or points. Let's go ahead and start taking a look at some of these examples. Alrighty, so example 1, again, I took the graphs from the book, which is all about matching situations to a graph. So it says the graphs show the speed of 3 snowboarders during a race. Tell which graph corresponds to each situation. So we're going to look at each situation and then kind of start looking at the graph and trying to interpret it. So situation A, if I go down here and read our situation, it says Jordan gets off to a good start. So if you notice, all these graphs start right at the origin or part in between the speed and the time. So I'm pretty sure all of them say they get off to a good start. So that means they're going to go, they're going to keep, as time goes on, their speed's going to increase. And then it says, and continues through the course, picking up speed. So, looking at my graphs, one starts off at a good start and continues throughout the course. So there's not a lot of different things that happen to this snowboarder. And so based on that, I can tell, like I kind of broke them up into those different types of lines in the first part. I can tell that there's probably not going to be a lot of different lines. And so in my best guess, and again, it's a good guess, it's not going to be perfect, but I'm going to say that graph 1 is Jordan. And I actually forgot my pen today, so it's going to take a little bit longer to write. I would say that this is graph 1 because he gets off to a good start. As he continues on, there's only one break in this, and then he just gets faster. He keeps, picking up speed and getting faster. So that's why the line kind of changes how steep it is, or that slope, if you know what slope means. So let's look at B. It says Ethan gets off to a good start and picks up speed. So again, kind of similar to Jordan here. Oops, I forgot to put the H in here. Towards the end of the race, he nearly falls and his speed stops increasing. He rights himself, or he fixes himself, and finishes the race, reaching his greatest speed. All right, so I only have graph 2 and graph 3 left. So someone who starts off at a good start. Then it says towards the end of the race, he nearly falls and his speed stops increasing. Well, if I'm looking at graph 2 and graph 3, what I notice about graph 2 is that about halfway through, it goes all the way down. I see this spike down here, or this decrease down here, that his speed goes down and his time goes down. So to me, this shows that he completely stops. Whereas graph 3, if I look towards the end, he almost falls, so maybe he's trying to fix himself, and I think that's kind of where this is going, because time continues on, but his speed isn't changing. He's not getting faster, he's not slowing down, or his speed stops increasing. So it just showed it stops. So he's not increasing, but he's also not decreasing. And that's what I notice right here when I have this flat line in graph 3. So for B, I would put graph as best as I can write with my little thing here, 3. But let's make sure, because let's look at the last one and see, does that really match up with graph 2? I'm not 100% sure. So let's see, I'm going to extend this. All right, so Xavier gets off to a good start, but falls around the middle of the race. Hey, wasn't I talking about graph 2 had something happen in the middle of the graph? I guess this is showing me his fall. He decreases in speed and he just falls. Because if you fall, you're going to be, if you fall and for at least a couple seconds, you're going to be flat on the ground. Falls in the middle of the race. He gets up and finishes the race, gaining speed through the finish line. And that's what I'm seeing, this gaining speed. He's continuing as time goes on. His speed's getting faster, and he's continuing on. So this last one, I would say graph 2. As best as I can write this. So that is what I'm talking about when I'm talking about interpreting these graphs. I'm kind of trying to find a situation that would best help these graphs, or best fit these graphs. So the second part, though, is we're going to be given we're going to have to create these graphs. But before we get to that, I want to talk again about these continuous graphs and discrete graphs. Because these graphs, graph 1, 2, and 3, are all considered to be continuous graphs. They're connected with lines. They can be straight lines, or they could be curves. In this case, we have all straight lines. So if I were to label these would be considered continuous. Remember then that anything with just dots is going to be considered a discrete graph. But it also could have a line depending on it, but it's going to be very, very distinct. Like, this is the direction it's going. It's not going to change directions, I guess is the best part to put it that way. So in example 2 here, I'm kind of blocking the directions. It says create a graph for each situation. Tell whether the graph is continuous or discrete. So in part A here, it says that the table shows the altitude, or how high an airplane is over time. So I have a table here. I have 0, 0, 10, 10,000. So this is a lot like the tables we were setting up for X and Y. So the time is my X value. My altitude is my Y value. So then if I were to make these coordinate points, for instance, the first one you'd have 0, 0. And this is kind of hard to draw with just the mouse. Okay, but what if I wanted to do like connect these ones? Okay, this one would be 80, 10,000. So what we would do is we'd set up a table or a coordinate grid like that. And if I had my normal pen here with me, I would set it up myself. But what I'm going to do is I'm going to show you the graph they have in the textbook here. So let me go ahead and move this or delete it. So here is the graph, and I will show you how they set it up. It's a little blurred just because there was a kind of a shine on it. But the bottom part is all of your time. So they have the time for the X, because this is the X value. That's why I'm putting the time on this line. And then the altitude is your Y. And it's okay that time, if you notice, time is going up by increments of 10. And that's all right. We can go by increments of 10. And it's okay that the Y is going up by different increments. So the Y, they decided to go up by increments of 5,000. So once they had that, they started plotting the points. Okay, 0, 0, 10 and 10,000, 20 and 20,000, 30, 30,000. I think then they went to all the way to 60, 60 or 30,000. And then it starts descending or going back down. So for this graph, that was how you would set it up, okay, graphing it out. Because this graph is continuous, or it continues, and it is showing me that it's not, it's not like, okay, I get to 10,000, I stop, and then I go up to this number. As the plane continues to increase speed, it's just being continuous. So this is a continuous graph. So for this one, I'm just going to put a C for continuous, just since my pen is not super great today. So that one would be labeled continuous. For B though, all the directions say is that tickets to a concert cost $15. So think about it. Okay, if I'm going to go to the concert alone, it's going to cost $15. If I go to the concert and bring a friend, well, each one of us are going to pay $15. So in total, we're going to pay 15 plus 15, or you can think 15 times 2, which is going to be $30. Okay, maybe I decided to bring my whole family. I have 5 people in my family, including myself. That means 5 times 15, which would be $60. So to set up a graph like this, same kind of thing, we're going to set up a coordinate grid. We only really need that first quadrant though. And here's how you'd set it up. My tickets would be my X value, so how many tickets I am purchasing. My cost is going to be my Y value. Because you could always write this as an equation, like I was kind of saying, as Y equals 15X. Because we're figuring out 15 times X, meaning how many tickets we're getting. That's going to show me how much of a total cost I create. And so each dot then would go up by 15. Okay, so if I purchase 1, $15. I talked about 2, it's going to cost me 30. I talked 5, is going to cost me, I did it wrong. 5 does not cost you 60. 5 would actually cost you, 75. That was my mistake when I was talking about the 5 here. So this is how I would set this one up. This is going to be considered a discrete graph, okay, because there's only dots. I did not connect them through. All right, so we will continue practicing this here in class. Let me know if you've got any questions.